yeah. Okay, I would like to share again all the social media accounts of Illustrados. If you guys love what we're doing, um, you guys can feel free to follow and like our Facebook and Instagram pages. We also have our website, and of course, we're on LinkedIn. So yeah. So hi again. I'm John from the content department of Illustrados Creatives and Technology. Illustrados for short. To give a brief introduction, um, sorry, to give a brief introduction, our company specializes in creating technologies, contents, as well as campaigns with just the right balance between art and technology. Whether it comes to website design, mobile app development, product photography, social media marketing, we make sure that everything we do is aligned with the current trends and effective strategies so we can produce impactful solutions. This is why we came up with our weekly skilled brewing event. Upon realizing the unrecognized ripe talent of people in our fields, our company has set a mission to cultivate creative culture. We set out to make an effort on bringing people from the fields of tech, creatives, content, and marketing together so we can all learn and, most importantly, stay connected. Which brings us to our topic for today, especially planned for people who love or are into artificial intelligence. Okay, so today we'll be going over artificial intelligence or machine learning. So, machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. Okay, guys, so our guest speaker for today is none other than Raphael Alampay, a graduate of Bachelor of Science in Management Information Systems, wow, a Master of Science in Computer Science, and a Doctor of Philosophy in Computer Science. He is also a managing partner at Cloudband Solutions Company and currently an AWS authorized instructor working with Trainacate Philippines. And his hobbies include doing YouTube videos, playing piano, and the guitar. So, without further ado, here is our speaker for today, Raphael Alampay. The floor is yours now, Raphael.
Hi, thank you. Thank you, John, for the warm introduction. Hello, everyone. And I'd like to thank Illustrados for inviting me for this talk. Hopefully, the audio is clear. Can I get ano ba, may thumbs up ba dito sa, sa Google Meet? Or just any signal that you can hear me? Is my audio clear? Do I need to increase the mic? Are we good? Okay. All right. All right. So good afternoon, everyone. Thank you for joining in this educational session on machine learning with Excel. So again, my name is Raphael Alampay. I'll be showing my screen in a little bit. Let me just start that. Okay. So before I begin, just a short disclaimer. I am by no means an I'm by no means an expert in Excel. So the only reason why I chose Excel as a format for the talk today is primarily because I think it's something that most people are familiar with, no? And with a topic such as artificial intelligence, specifically machine learning, um, it might sound complicated for some people. It might seem intimidating. So hopefully, I'd like to sort of simplify it into its core fundamentals, and hopefully that everyone may be able to apply it. Okay, so I believe I've already been introduced. My agenda for today will just be threefold. I'll just talk about what machine learning is in general, and what two sort of popular algorithms are used and that can be implemented easily in Excel so that you can get started with machine learning. So I'll just discuss a tale of two algorithms, and then I'll talk about biology in Excel as well. So later on, hopefully, we understand why it is called biology. Okay, so I guess no need for this introduction. Okay, let me start off with a meme. Every time I'm actually I was associated with Ateneo before in terms of teaching there, but right now I don't teach that much. But whenever I do, I often like to start a presentation with a meme. Okay, so in this case, this is the best meme I could find about Excel. Usually, Excel is a very common tool that most people use, especially in the finance world, right? Maybe some of the companies you've been engaging with still use Excel as one of their common tools to perform some sort of numerical processing, especially in finance. And there's a joke going around that it does carry the entire financial system of the entire globe, but not really. Okay, so expectations. Again, we'll discuss what machine learning is on a very high level. I hope that by the end of this talk, everyone has an idea of what machine learning is and that it's not something magical or it's not something as complicated as what most people may seem. Now, machine learning is largely involved with mathematics. So we will be doing a little bit of math. So for those who are allergic with math, such as myself, I like solving problems, but I'm not necessarily in tune with math unless it's something that is related to the problem I'm solving. But we will have a little bit of math, as well as some intuitive learning, right? What are the concepts that we can sort of digest and then sort of apply it to our own problems in life? Okay, so maybe you could share this along the way. Although I did scan the chat earlier a while ago, maybe I could skip this, but feel free to share any experiences or expectations when it comes to machine learning. What maybe you have some dreams or aspirations to learn more about artificial intelligence. What do you hope to get out of this talk? Feel free to leave it in the chat, and I will maybe address them later on when we have time. What I won't be talking about how to implement a what you call a fully connected neural network. We'll see why that is the case because sometimes when we hear the term artificial intelligence, we often think of neural biology, right? How the brain works, and it's actually related to that. I'll heavily use the analogy of a brain and how a computer sort of models the brain. Right? I also won't talk about what the best algorithm is because the thing with machine learning is that there's no silver bullet, meaning there's no one algorithm, all knowing and all powerful AI that is able to solve all possible problems. I also won't be talking about regression. So, what is regression? In simplest terms, regression is about predicting the outcome on a future state, right? Unlike, for example, the stock market, what is the future price of a certain stock? I won't be talking about that. Right? I'll mostly be focusing on classification, and we'll know why later on. Right? Okay, so a few things first. Let's start off with the big picture. What is machine learning? So, machine learning is a branch of artificial intelligence. It's not necessarily artificial intelligence, but it is considered a branch of artificial intelligence. And the reason behind this is because machine learning is really just a fancy term for multivariate statistics. So if you've taken up like a basic statistical course, for example, computing the average, when you compute the average of a bunch of numbers, right, and then you divide it by the total number of elements in your list, for example, that's what we call like a univariate statistics because you're just considering one aspect of measurement. Now, if you take multiple aspects of a certain measurement, then you're performing multivariate statistics. And machine learning is sort of that thing. You take a bunch of numbers that sort of is related but not quite, or could be related to one another, that characterizes certain aspects of a problem. Okay, so, for example, if you're trying to predict the weather, you simply don't say that the weather tomorrow is sunny or the weather tomorrow is rainy, but rather you characterize it according to things like humidity, temperature, color of the sky, right? So just by those things alone, those are variations of characteristics that we consider, variations of data that we consider, and that could be considered as machine learning. So really at the end of the day, machine learning is about multivariate numerical processing, if you will. But it can further be categorized in three types. So when you sort of get into this field, there are three common paths that you could take with machine learning. Machine learning can either be supervised, semi supervised, or unsupervised. Okay, so let's sort of break that down first. Now let's break that down by discussing a machine learning problem, a very simple problem. Let's say we want to recognize, or let's say we want to build a computer, an algorithm that is able to say or distinguish a dog from a cat. Well, for us human beings, it's quite easy, but in actuality, the only reason why we recognize a dog from a cat is because of years of experience. Right? If you imagine, if we were the first human beings, we don't even have the concept of what a dog is or what a cat is. So fundamentally, us human beings are performing machine learning. We take note of the data of how a dog is a dog, of how a cat is a cat, and from there we make a distinction. So on a very high level, that's how we solve what machine learning problems, right? We would like to have certain categories or characteristics wherein we'd like to determine if one can be called a dog or one can be a cat. Now, how do we approach this? So let's say we approach this in a supervised learning way. Again, what is supervised learning? It's one of the approaches in machine learning. Supervised machine learning means that in order to distinguish a dog, I need to know what a dog is a priori or previously known, right? So what I do is I might get a lot of pictures of dogs, right? Be familiar with it. I get a lot of pictures of cats, and then my brain is sort of trained to know what the difference is between a dog and a cat. It's the same methodology that you'd actually give to a child, right? Let's say you have a newborn child, show them pictures of dogs, and train that child to say that this is a dog and this is a cat. This is a cat. So that's what we mean by supervised learning. We're actually telling the machine or some smart artificial entity that something is a dog or something is a cat. We feed it to the model, then we profit. The second type of machine learning is what we call semi-supervised learning. Now, the term semi means partial, right? So the idea there is that in its simplest case, again, in a domain of our problem, how do we distinguish a dog from a cat? We simply take a lot of pictures of a dog, we be familiar with what a dog is, and anything that is not familiar with a dog is essentially a cat. Of course, that's not practical, but that encompasses or that characterizes what semi supervised learning is. You sort of have partial information of what something is, learn from that, and then anything that is not that thing that we are looking for. In this case, not a dog, or in our problem domain, not a cat. So we just feed the model what we call positive information. Not no negative information or no other categorical information. We learn what a dog is. If it's not a dog, then it's a cat, and then we profit. Now, the third type is probably the more realistic one, what we call unsupervised machine learning. And unfortunately, we won't talk about this, although I could give examples when we have time. And it's the domain that I am most interested in because unsupervised machine learning simply says that I get pictures, I feed it to a model, and then I profit. Meaning, I allow the data to tell a story about what something is. I might not get dogs, I might not get cats, but I will allow the data to tell me what sort of animals exist within my data set. So those are the three sort of branches of machine learnings, and those are the general approaches um, that we would take if we want to solve certain problems in the machine learning domain. Okay? Now, if you get that concept, then you already know what machine learning is, at least on a very high level. The rest of the talk will actually focus more into the actual details because we do have an implementation part. We have the Excel part. Right? But before we go there, let's get some terminology straight, or the lingo, so to speak, of what different terms are being thrown out in the world of machine learning. So the first one is what we call feature vector. Feature vector is an array of numbers representing an entity. Now that might sound complicated, but really what it's saying is that it characterizes something, an entity, like a dog. Like for example, if I were to tell you, please describe to me what a dog is, they probably say, well, a dog has a tongue that keeps sticking out. A dog has four legs, for most of them at least. A dog has a single tail. A dog has two eyes, etc. Right? So they are simply an array of something that can be measured. That's why specifically the definition here is that it's an array of numbers. As long as we can have our characteristics reduced to any numerical aspect. So a metric, something that we can compute on, we can include that as part of our feature vector. Dimensionality, the second term, is essentially the size of the feature vector. And the thing with machine learning, or at least the rule in machine learning, whether you do supervised, unsupervised, or semi-supervised, is that the dimensionality should be the same. So for example, if let's say we are gathering data of what a dog is, we have number of legs, number of eyes, number of ears, number of noses, number of mouths, for example. So those are what? Five characteristics. It means that each feature vector of a certain dog should always have a dimensionality of 5, which is the size of our vector, the size of our attributes that we use to describe a particular dog. Now, if you understand that, then you're almost there, right? You understand that each entity can be is uniform in nature and in the way that we describe a dog, in the way that we describe a cat. The third term, algorithm, is well, in a general sense, algorithm means a step-by-step process to solve a particular problem. When we take it into the context of machine learning, then it's the same thing. What is a step-by-step process that can allow us to learn from our data? Now, model and our algorithm are sort of interchanged, but I'd like to make a case that they are actually two different things. If algorithm is sort of your methodology that you have to follow in order to learn a particular aspect, then model means that it is the output of our algorithm. It represents our solution. We'll get a bit mathematical later on, but for now, algorithm is the process and model is our output, essentially. Right. Now, what about weights? Well, weights is mostly a mathematical term. It's actually the numerical coefficient of your dimensionality. And basically, what it means is that how well do we prioritize something? Okay, so, for example, you've actually been doing machine learning ever since you were born. For example, how do you know that a kettle is hot? How do you know that a pan is hot? Well, you do so by learning from it. You touch something, you have sensory inputs in your fingers, you realize that the temperature is too high for you to tolerate. And so you sort of remember it. So you put a high weight on something that is hot so that it triggers your brain and you tell it, hey, please don't touch that again because it's hot. It has smoke coming out of it. It feels hot. It looks hot, right? So the weights is essentially the importance of what you would prioritize, or consequently, what would you deprioritize, right? So I know there's a lot to take in. So we'll encounter these problems again, or rather these terminologies again, as we explain the different algorithms of machine learning, right? So let's now get a bit mathematical. So just for those who took up, I don't know, was this grade school or high school algebra? Who can tell me what this equation is? Okay, John de Guzman says it's the slope, correct, or otherwise known as the equation of a slope intercept. Yes, it's the equation of what? What drawing does this sort of express? It's a slope. So if something is a slope, yeah, okay, right. So who was that? Lawrence, right? So Lawrence said it's the equation of a line, which is correct. And really, it's the only equation that you need in machine learning. Right? If you know how to interpret the equation of the line, then you're essentially doing machine learning mathematically. Now, let's simplify it further. We know that if you have a function, f of x is equal to y. Now, take note, if I keep on switching these two equations, they're actually the same thing. Mx plus b will be some sort of answer, and y will be some sort of answer. Now, going back to our dog versus cat problem, that problem can actually be characterized by this equation. F of x is equal to y, where y can only be two possibilities, a 1 or a 0. So remember, the purpose, or rather, in order for us to do machine learning, we have to reduce everything into something numerical. So in our case, if we were to reduce a dog and a cat to something numerical, we could probably say a dog is 1 and a cat is 0. Mathematically, they can be represented as numbers. In this case, I would say that's much easier to digest. right? We understand what y can be. Y can either be 1, y can either be 0. And we know that if you switch back to the previous equation, y is simply the result of mx plus b. So in other words, what we don't know yet is what f of x is. Now we can think of f of x as our algorithm. Okay, and again, what is algorithm? Our step-by-step process in order to come up with a solution. Okay? If f is our algorithm, what is x? Well, if you remember from algebra, x is something that we put inside a function. It is what we call our parameter. In the case of machine learning, x is often denoted by our unknown data point. So going back to the problem of what is a dog and what is a cat. So if I were to give you, let's say, this one, right? Right? This is not a dog. This is not a cat. But this could be our ex. Not our ex-girlfriend or not our ex-boyfriend, but our ex, our unknown. We don't know if we would categorize this thing as a dog or a cat. It's essentially what x is. It is some metric with the same dimensionality as a dog or a cat that we'd like to know about if it is a 1 or a 0. Now, let's get a bit nerdy. The equation f of x equals mx plus b can actually be expanded. Right? Now, for those of you who answered the slope thing, that's correct, right? When you say b is like the y-intercept, and then you have m right beside x. And that actually goes a long way. Let me just go back here quickly. So, x is beside x because we say that, x is beside, m is beside x because we say that m influences x. Now, if you know your mathematics, you know that if two letters are beside each other, then they sort of express a product, right? It's a multiplication operation. Okay. Now, if you remember the term weights, right? How did we define weights? The numerical coefficient of dimensionality to come up with a solution. Or in other words, how do we prioritize something? Naturally speaking, the larger the m, the steeper the slope, or in maybe layman's terms, the larger the m, the larger the number that we multiply to x, the more important, sort of the higher its importance. Right? So if I had an x of 100, if I had an m of 100, that means that it's 100 times more important than if m was equal to, let's say, 1. Right? So the m is sort of the weight that we give to our x. If you want to forget your ex, your ex-boyfriend or your ex-girlfriend, you deprioritize them. You might give them a negative value or a negative evaluation. Right? Now, let's expand the term. We said that in machine learning, you have some sort of dimensionality, right? Because you want to measure a dog by the number of legs, the number of tails, the number of eyes, etc., etc. So each of those elements are what we call different x's, right? X sub 1, x sub 2, x sub 3, and each of them has their own corresponding weights or corresponding importances. You have a lot of x's, you have a lot of importances against them, a lot of weight against them. Let me speak freely here. So kung na-trauma kayo ng x nyo, syempre negative na yung w ng x na yun, right? You don't want to have that, you don't want to repeat that same mistake again, right? So you give a less importance to that. Or in other words, if you want to forget your x, what would the value of w be in that case? Anyone? Forget your x. What m or what w would you give in order to forget your x, mathematically speaking? X na. Yes. Yeah, so Sean got it correct. So baka may experience si Sean. No? You give your x a 0. Why? Because anything you multiply to 0 is equal to 0. No importance at all. Negative, affected ka pa. Positive, mahal mo pa siya. No? So, now, let's go back to the equation of a line. Well, if we translate the y f of x equals mx plus b, we're essentially creating a line. Now, for those of you familiar with math, it's otherwise known as the Cartesian plane. We sort of project the Cartesian plane into different dimensionalities. So let's just say in this example that x sub 1 is a characteristic of a dog or a cat, and x sub 2 is another characteristic of a dog and a cat. Now, depending on the weights that you give x1 and x2, your line sort of, hopefully you can see my camera, right? I'm moving my arm. It controls the steepness of the line. Right? We know that a positive x would have sort of a right-leaning line, sorry, a positive m rather would have a line leaning to the right, a negative m would have a line leaning to the left. And that's essentially what machine learning is. We'd like to draw the line, we'd like to find the proper w's for our x's in such a way that we draw a line for multidimensionality, in order to separate dogs from cats based on how they are characterized. Now, I couldn't actually draw multi-dimensionalities on screen because as human beings, we can only comprehend until arguably the fourth dimension. In fact, here in 2D space, we could only comprehend two dimensions. But in real machine learning problems, like for example, natural language processing, wherein like you like to sort of get the sentiment for an article, if it's sad, happy, um, bad, or angry, or something like that, then you'd most likely may have more than one X. So as human beings, it's actually hard to visualize multidimensionalities, and so we need software for it. We need mathematical models. We need computers to do it for us, such as Excel. But the fundamentals are the same. We are looking for a line that allows us to separate cats from dogs. Now, a note about the line. This is not the only line that we can draw. If you notice, depending on how the pictures are situated, we could have some sort of steeper going line, which is also a viable solution to our problem. However, we're not sure where another dog or cat would appear. So that taking our X again, this water jug right here, if I throw this water jug with its own sort of x1 and x2, the question is, where in the line does it fall? Does it fall above the line? In that case, it's a cat. Does it fall below the line? In that case, that is a dog. Okay? Hopefully that's quite clear. Right, let's now move into an actual machine problem so that you can sort of have an idea on how problems are formulated in machine learning. What is a dog or what is a cat? Now, I always like to use this example because Ryan, not his real name, is a student of mine who actually keeps sleeping in class. So I use his name here. So Ryan, not his real name, has a crush on a Starbucks barista. He'd go to Starbucks on a daily basis to order his favorite drink just to chat with the barista. The barista seems to be responsive and talks about non-coffee stuff with Ryan. Making sure not to get his hopes up too much, Ryan wants to know if the barista is A, flirting with him, or B, just really, really nice. Okay, that's the most lenient way I can put it. So, why is this a machine learning problem? Well, it's obvious that Ryan, being a scientist, would like to know if he has a shot with his barista. So, he'd like to predict based on being a good scientist, he'd like to base it on empirical data and wag lang siya mag-assume. So otherwise, pag nag-assume ka, it's as good as flipping a coin, right? May crush ka, diba? Sige, wag na tayo mag-machine learning. Let's just flip a coin, heads or tails. Tayo na pag heads. Hindi na tayo pag tails. Right? Wag mag-assume. Correct. Masakit mag-assume. So, machine learning is the path to happiness because you won't assume. All right. Glad we have that clear. So, again, first step, we'd like to reduce it into its numerical form. Again, we'd like to have a fixed set of dimensionality. So let's try to model it in terms of our x's and our y's. Our y is pretty obvious. Sorry, let me just backtrack a bit again. Right? Y is our answer. We need, in a supervised way, we need to gather data wherein we already know what y is. We already know what 1 is. We already know what 0 is. In the case of this, kukuha tayo ng data sa mga malalandi or sa mga mababait lang. Okay, so either really, really nice or, flirty, right? So in that case, we'll have A's or B's just to model it similar to our problem. You could, of course, model it as either 1 or 0. Now, what is our X? Well, our X is our dimensionality. What are the characteristics that will allow us to describe someone who is an A or someone who is a B? Okay, again, we already know this. That's why we sort of, maybe Ryan asked his friends who are known to be flirty. Ryan asked his friends who are known to be just really nice. And then we sort of gather data. So let's say we measure someone who's flirty or someone who's nice according to the number of smile he or she takes, I guess the person, the length of the chat, and the length of the eye contact. Again, I'm just making this up. This is just theoretical, but it's a good way to model machine learning. Okay? Because they can be measured in numerical values. Now, this is quite obvious because if you notice the B part, what is our B? Just really, really nice. Sort of have low values in each of the X, right? 1.5, length of eye contact, none at all, zero. So that's pretty obvious, right? At the same time, someone is quite flirty based on the number of smiles, length of chat, and the eye contact. Okay, good. We have our X, we have our Y. Now, what is missing here? What is missing here is what would be the W's that would allow us to distinguish X and, or rather, what are the W's? What are the importance that we should give to each X for us to come up with an answer Y? Okay, that's what we don't know yet. And that's what we will try to tackle with a tale of two algorithms. Answering the same problem. Um, okay, hang on. If you want to try this out, let me just. Not sure if this is public or not sure if I can share this. Let me know na lang kung if I can share this. So I will 1 minute eye contact. Yeah, it's quite a lot. If you want to play with the numbers, I've shared the slide set over. I think it's shareable. It's okay, I think. Okay, so how do you apply it? Well, there are a lot of machine learning algorithms out there. For this session, since we're time limited, I'll only talk about two. We have what is called KNN, and we have what's called the single perceptron network, both of which we will implement in Excel. So, K nearest neighbors, given data points X, this one, and their labels Y, going back here, this one again, get K nearest neighbors of some unknown point. Okay, so what is our some unknown point? Our some unknown point is this thing. We'd like to know if this thing is really flirty or just really, really nice. Okay? So the idea there is to declare some K. And this is where the trick of the algorithm comes in. How many nearest neighbors, okay, can be from this unknown entity that will actually tell it if it's an A or a B. So that's the idea of K nearest neighbors. Tayo bahala kay K, right? I may say 3 nearest neighbors, I may say 4 nearest neighbors. In machine learning, we call this a hyperparameter. It's something that we tune to get the best results according to this algorithm. Okay? And the idea there is that from the K nearest neighbors, we select the majority of labels. And since we already know those labels, we characterize them as our unknown. In other words, it's another term for peer pressure. Let's say you have a group, right? 5 of your closest friends. If 3 of those 5 of your closest friends say that, take a shot, ligawan mo na yung barista yan, then that's what you would do. But if 3 of your 5 closest friends, which is majority, um, would say, wag yan, pre, ano yan, trabaho niya lang yan, parang ganun. Then of course, hindi mo gagawin. Right? Kasi na peer pressure ka, essentially. Right? So that's what K nearest neighbors is, essentially. Okay, so let's see how we can implement that. Okay. Let me open up an Excel spreadsheet here. You can use any Excel spreadsheet. I'm just using the one on Google Docs. So that's something that we can easily implement. Okay, let's formalize this. So let's say, hopefully everyone can see this. Ayan. X sub 1, X sub 2, X sub 3. Why? Because, again, this is our data, which is laid out here in our table. Okay. I should have prepared these earlier, but let's just do a few of them. So 5, 12, 1. And then we have 6, 10, and 2.5. Let's see how fast I can do this. Feel free to do it as well. 4, 8, 0. I know these are 0. And then let's see, 1.5, 1.5, 1.5.1, And finally, we have 0 and 0. Okay, hit 0. All right, and then we have our Y, our data a priori. We already know this, that the first three rows are A, and the last three rows are B. Now, now that we have formatted it this way, hopefully everyone can still follow. Let me know if I'm going too fast. How do I format this? There you go, something more special. Okay, this is what we refer to as our data set, our known data set. Because again, we are performing supervised learning, supervised machine learning. We're in. We know which ones are considered A, which ones are considered B. Now, paano si Ryan? Well, let's say at row number 8 in my Excel here, siya si Ryan. So, sorry, not si Ryan. We're not solving for Ryan. We're solving for the barista, right? We like to know if the barista is an A or a B. Okay, kaya nabahala ko ng label ni A at B. So, we gather sort of metrics. So, ikaw si Ryan, obserbahan ko yung barista. No? Is it, okay, so just give some random numbers here. Randomize. How do you do random in Excel? You can choose any random number. Multiply it by 5. But again, the point here is that we'd like to have some numbers that will allow us to measure what our barista is exhibiting according to these values. Okay. You can have any numbers you'd like. Kaya bahala. It doesn't matter. Now, let's go back to the definition of KNN. Again, we don't know what this is, right? We don't know what the barista is. Is it an A or a B? According to our definition, KNN gets the K nearest neighbors. So, how can you say, how do you think? I'll actually return the question to everyone. How would you think, or how would you say that something is closer to something? Let's say right now I'm in Quezon City, right? How do I say I'm close or I'm as far away to Makati, for example? How would you measure that? In kilometers, right? We have a particular metric that measures distance. So in other words, we need some sort of distance function. Oops, not that yet. We need some sort of distance function that determines the barista, row 8, versus our known A, as well as the other known A's and B's. I like to know how far this row is from this row. And there are many distance functions out there. Now let's sort of lay it out here. We'll say this is the result of our distance function. Again, a distance function is a metric, a single number that allows us to measure how far we are from this one. So, one popular distance function is what we call the Euclidean distance. Now, it might sound complicated, but really it's a concept of geometry to determine how far one point is from another. That can be easily computed per dimensionality of our row. So what do I mean by per dimensionality? Per x attribute of our row. So it means that for x1, I'd like to know how far is this characteristic from this characteristic. How far is this characteristic from this characteristic? And for x3, this characteristic versus this characteristic. Okay, so how does this go about? Well, the Euclidean distance is simply the official formula is the square root of the sum of squared distances. Wait, that might seem a lot, but let's break it down. What is the squared distance of x1, of x2, and of x3? What I'm doing here is I'm just getting like a column for the distance between the barista, our row number 8. Zoom this out. Row number 8 versus each attribute of each data row here. So let's try the first one. X1, so this would be squared distance. But really, what is distance? Well, distance is really just the difference between two numbers. And that's something we understand, right? It's just the difference. Minus, minus, right? And then we sort of square it. So this is the distance between x1 of the barista and then x1 of a previously known a. You can sort of drag it here, see if it's computing correctly. Okay, so it's computing correctly. This one as well. And then we sort of have our distance function is really the sum. We do a sum in Excel. The sum of all these distances. So here in column H, this is the distance of the barista vis-a-vis our first data element, which is a previously known A. And the rest is the same approach, right? Let's see how we can do this. Well, our A8 is actually constant, so we can anchor this. Same goes for this one. We anchor this. And we sort of drag it down so that it follows the same rules as the others. Even Google Sheets, it's sort of uh, okay, let's do that. Right. Just see if it follows the same. Right. So it's computing the correct cell. Right. Same goes for this one. Everything is a number. And then we sort of just drag this here. Right. So columns E, F, and G, these are just sort of the broken down versions of the problem. And then H is the sort of the final distance count because we just really need a single value representing our distance. Now, according to the K nearest neighbors algorithm, what's next? Well, we declare K. We want to say what is the nearest neighbors, who are our peers, no, that is closest to us according to the distance metric. Now, looking at these numbers, who would be that? Let's say K is equal to 3. Again, K is a hyperparameter. It's something that we tune in our algorithm so that we come up with some sort of ideal model. Okay, let's check this out. I don't know how to sort things in Excel, so let's just go ahead and eyeball it. Who are the 3 closest data points? So that would be, I would say, 1, that's the closest, 30.54. 2, that would come in second place, I guess. And then 3, the 3 nearest neighbors. Okay. Now that we have the 3 nearest neighbors, what's the next thing? It's essentially peer pressure. We now take a look at their Ys. Now, what do you notice about the Y? Who is the majority among our nearest neighbors? B, right? So, what do we say about the barista? Is our barista flirty or is our barista just really, really nice? According to this, mabait lang pala. Okay, so, poor Ryan, no? Maybe as a shot, but that's, well, facts over feelings, diba? So, um, yeah, sad boy na si Ryan, unfortunately. Well, according to machine learning, Ryan's crush, unfortunately, is just really, really nice to him. I mean, we don't control it. The machine learned about it, right? Okay, okay, try nyo mamaya. Well, you need to gather a bunch of friends, no? Gather your data like a real scientist would. No? Okay, pumpkin spice. Okay, to increase the W, pumpkin spice, right? Okay, so hopefully everyone got that across. No? Now, let's try to be a bit, or let's try to think out of the box. And it's a question I usually give my students whenever I present this problem. Since K is a hyperparameter of the algorithm, what do you think a problem might be if when it's in K? What do you think a problem would be? Because remember, we chose K, right? So what could be a rule of thumb when you choose an appropriate value for K, according to how you understood the algorithm? What could be a problem? Anyone? If it's too small, yes, you're actually just relying on like your really really closest friends, and you really put some trust in those closest friends. So yeah, the margin of error could be huge, no, because you're sort of not considering the opinion of your other friends. Yeah, sample is small. Yeah, so we're talking about if the sample size is statistically significant. But what I'm trying to drive at is, what about the value itself? Very basic question. What about the value itself? What could be a good rule of thumb for the value of k for this algorithm to work effectively? And I'll give you a hint: peer pressure. Yeah, let's just say that like the data is statistically significant. You get a good balance of people who are flirty, or people who are just really nice. But what about k, and how will k affect your decision as a machine learning entity, as a machine learning algorithm in this case? Anyone? Why did I choose three as opposed to, let's say, four? What's the danger in between choosing four and three? Actually, I would choose three over four. Okay, so Sully here says it's odd, right? And that's actually the correct answer. I'd actually choose an odd number over an even number for k. And why would that be the case? Why do you think? Right. Because you want to have a decision maker. Like, what happens if you choose four? There is a chance. Yeah, it's actually correct. No, because Karl says majority rule, right? There is a chance that if you choose an odd number, um, then there could be a tie, right? If it's a k is equal to four, and it just so happens that four of my nearest neighbors, two of them are flirty, two of them are just really nice, then it's as good as just flipping a coin. Okay? So that way of thinking is sort of the challenge in machine learning. It's really about tweaking those hyperparameters. Okay. Oops, I think I got disconnected a bit. Okay, hopefully, I'm still here. It's about tweaking those hyperparameters in order to come up with the best solutions. In the case of k nearest neighbors, one classical optimization for this is to choose an odd number compared to an even number, right? Because an odd number would allow a better chance of having a majority. Okay. Right, so that's for the first algorithm, and hopefully everyone um, got that concept across. If you did understand that, then congratulations. That's your first machine learning algorithm, a step towards more intelligent computation on making decisions towards certain problems. So with that alone, you can already do a lot of applications for it. But the trick there is to have data. That's why in today's world, they sort of say that data is the new oil, right? Back in the industrial age, the world valued oil, crude oil, because they wanted to run machines. But machines are sort of analog, clunky things. They still need manual processes to operate. Now, in the modern world, the age of information and digital technology, a lot of data is available out there, and it's really it's data that drives society. Like, for example, the whole psychology of Facebook and Instagram, right? The reason why to have those likes is not just to like feed your ego, but rather it's there to sort of tell a story as to what people actually prioritize. So if you think of it in terms of our machine learning problem, Facebook is allowing the data that you find in Facebook is allowing us to determine a good model as to what people actually prioritize. That's why if you tuned into the latest news on the Pandora Papers, or the Panama documents, right? Information leakage is actually a very, very dangerous thing. It actually gives us a picture on how these machine learning algorithms can be weaponized. Yes, it does have value in marketing, in making these large data driven decisions, but it can also be weaponized to steer the public or society into chaos. So even if this is a very simple equation, it's actually one of the most important equations of the 21st century. Now, Let's go to the second one. Okay, so I forgot to show this visualization. This is essentially what K and N is, right? You have some data points, you have an unknown, you get K number of nearest neighbors, and your K will of course affect your decision, right? So for example, if K is too small and K is equal to 3, in this case, no, you might classify the green one as a triangle. But if you increase your K, it's possible that your green circle is considered a blue square. So there's no silver bullet. It really is about um, making sure that you have the correct hyperparameters and then you validate your result. So in the case of Ryan, well, validate his result. Wag niya patulan yung barista. No? Pag kumabol pa si barista, di mali yung machine learning algorithm. May chance pala siya. Who knows? It's not a silver bullet. It's something that we have to work on as scientists. Okay, so we already did the demo. Now, the second algorithm I'll be talking about is, I would say, much more complicated. It's what we call the single perceptron algorithm. Now, the single perceptron algorithm is considered a neural network. So this is where sort of the biology part comes in. You want to train a single neuron. That's why it's called single perceptron. Wherein, again, I'm not an expert in biology, in fact, but this is just how I understood it. Right? So in our brain, we have a lot of these receptors or neurons, sensory things that reacts to chemical reactions. And machine learning or data scientists actually took the same concept and then they sort of modeled it mathematically. Right? In our brain, we have a lot of signals firing off that will tell us if something is hot or cold, dog or cat, flirty or non-flirty, etc. And the process is that given the same data points, so we're still solving the same problem but using a different algorithm, given the same data points, determine a set of weights that prioritizes each dimension. So this is where it gets tricky because the value of W, in order to fit our model, it's very hard to solve because each W is a continuous set of values. How many values do we have? Well, almost infinite. From 0 to 1 alone, we have almost infinite number of values in between them. If you were to sort of brute force that just to model what the proper W is, then it would be very difficult to do. So what the neural network does, or what the single perceptron does, is that it trains weights. It has this process called a training process that optimizes W in order to get the correct answer. Now, to better understand this, let's say you're taking a quiz. No? In order to be good with a quiz, you have to know your mistakes. You answer some sample quizzes, and then if you make a mistake in that quiz, you adjust accordingly because you remember now what the correct answer is. The same goes for a neural network. You essentially try, so this is a picture of a neuron, you essentially try things out. For example, if I were to determine if something is hot or cold, I would have to touch it. If the sensory input detects that something is too hot, I get hurt. I remember that I give an importance to the heat or to the temperature. Okay. Uh, okay. Now, okay. So that's the idea, right? Now, based on that, the single perceptron algorithm will adjust its weights, and then it will try it out again. So maybe when I touch something and I know that my finger cannot handle the heat, I will wear gloves, right? So I will adjust accordingly in order to determine if something is hot or cold. Now, how does it work mathematically? Well, that actually depends on the signal to actually fire off. Right? Our neurons in our brains will have to fire off a signal based on the W's that is dictated and then adjust accordingly. Now, mathematically, that looks something like this. We simply multiply an initial set of W's, something random, right, that we don't know yet, okay? And then we fire off that signal, regardless of it being correct or not. Okay? So W1 times x of 1, W2 times x of 2, W3 times x of 3. Randomize those things first, fire off a signal, So what does a signal look like? Well, the signal is what we call an activation function. There are a lot of activation functions out there, but one of the more common ones is this thing called the sigmoid, which fits a value between 0 to 1. As complicated as it sounds, it does have a closed form, 1 over 1 minus e raised to the negative e. So being a closed form, it's something that we can implement in Excel. So we essentially take the product of the weights multiplied by x. Now, don't mind the b yet. Just think of b as some constant. You can actually set b to 0 for now. But essentially, after we take the sum of everything, we fire it off. Now, where does the training come in? The training comes in given some formula called what we call the uh, in formal terms, we actually call it the gradient descent. Wherein, based on some error metric, which is the distance between our guess and the actual guess. Right? What is the actual guess? Well, the actual guess is already something that we know. Going back to this data, something that we know. Okay? So we could actually easily convert this to 1, 1, 1, 0, 0, 0. This is what we know. We take a bunch of W's, multiply them, sum them, pass them to our activation function, and luckily for us, the sigmoid function fits a value between 0 to 1. So we know how far that value is from either a 1 or a 0. That difference is then plugged into an equation here. That difference is then plugged into equation wherein we adjust W. Okay, W sub t minus 1 is actually the W right before the next thing that we are examining. Okay? So the new W will be the previous W plus some learning rate. You can think of the learning rate as to how fast. It's like another hyperparameter, right? That we tweak. That shouldn't be too high or it shouldn't be too low depending on our problem. Because the higher your learning rate is as if you're saying, I'd like to study faster. But sometimes we know that if we study faster, we might not remember things or we might skip things quickly. At the same time, if we have a lower learning rate, we study slower, but we might not be able to finish everything that we study. So we might not be able to learn everything. It's another hyperparameter that we tweak, wherein you multiply it to the target, what we already know, minus our prediction. Now, what is our prediction? Our prediction is whatever the result of our activation function is. Okay. We'd like to get that difference, multiply it by some learning rate, and see how it affects our previous x, our previous measurement. We add it to our previous weights, and that becomes our updated weight. Now, I could go through the whole proof of this, but for now, let's just assume that this equation is correct and that it allows us to adjust, right, the weights until it relearns everything. Now, this actually goes a long way because it means that the single perceptron algorithm has to repeat looking at the data over and over again until it perfects how it recognizes the data, until it can learn how an A looks like, or how a B looks like, how a 1 looks like, or how a 0 looks like, based on this formula. Now, here's another question. How will you know that the model actually learned? Intuitively, based on how I explained what the single perceptron algorithm is. How will you know that the model already learned or has already studied good enough? What would your target be in this case? Or sorry, what not target in this sense, no, but what indication in this formula would tell you that you're good enough, numerically speaking? Anyone care to take a guess? Target and prediction is close, correct, right? If your target and your prediction, wherein if you subtract it, is close to 0, then it's as if you're almost perfect. But the thing with machine learning, and this is a very important lesson in machine learning, we don't want it to be zero. Why don't we want it to be zero? Because zero is too perfect. If you're too perfect with something, maybe it's like taking a quiz, right? You memorize everything, but you're only good for those items. You're not generalized enough, right, to know about other items that might occur, right? So that's the sort of the what do you call it? The irony here, right? We want to be as precise as possible, but in machine learning, we don't want that. We want to be almost perfect, but not quite. Meaning target minus prediction should not be equal to zero. So how does that look like? Well, it might look scary now. So let me share the link with everyone. So mathematically speaking, again, we don't want to. So what do we know about this? We don't want to be zero. At the same time, we need to do things over and over again. Okay, until and an indication to know that we are actually learning something is that the margin of error, how close we are to our target, is actually going lower and lower or is approaching zero. Now, to give you an example, in this Excel file, we have here our data. So these are just a bunch of values I came up with. But at the very least, hopefully, we already know how to read this. Right? Let me just zoom this out a bit. So how do we interpret this Excel? Well, this is our data, and this is our y, okay, all zeros and ones, right? And this is what we will train on. Now, what did they say about the single perceptron algorithm? Similar to how we were born, right? We were born with not knowing anything. So our brains, the weights of our brains are actually randomized. So these values are just arbitrary values, which we call initial weights. As you can see, the initial weights have um, the same dimensionality as our x's because each x should have a corresponding w. Now to the right, you have in column E number of iterations, wherein each iteration is actually the machine going through all the items as if it were performing a quiz, right? I'd like to answer the quiz based on the importance, okay, and on item number one and see if I can come up with zero. Now, how do we do that? Well, we follow the equation in the slide. We multiply W1 by its corresponding X1. We multiply W2 by its corresponding X2. W3 by according to its W3 with X3. Again, you can disregard B for now. B is what we call a bias, but we're not going to too much detail. So for now, you can just treat B as 1 as a constant, but it is included in it. And there is a sort of a scientific explanation about it. But for now, let's just treat it as a constant of 1. Now, once we get the products of those, we simply sum it up. Okay? Column Q, that would be our sum. And our prediction is the formula you've seen earlier, the sigmoid function of 1 over 1 plus exp raised to Q3. I'm lagging. Let me just turn off my camera for a bit. Camera. Okay. Uh, okay. So prediction is our sigmoid function, 1 over 1 exp raised to negative q3 raised to our x, I believe, right? Which was this one, q3, right? And then we know our target. So just like reviewing for a quiz, we'd like to know our difference. Now, remember our difference from k and n? It's simply the squared difference of two values. And what are those two values are? What are those two values? That would be our prediction minus our target. How far is 0.589 to 0? And then we square it. After we square it, in the next row, okay, so now that we know this, it's as if we are saying, using the learning rate example this time around, W sub t minus 1 is the previous W. So it's as if saying, based on what I already know, the mistakes I did in the previous question, let's see if I can apply a change of that. Because I had an error term, right? How far was I from the answer? Okay, I have some magnitude value. I'll use that magnitude value to affect my answers in the next question. Okay, so I do the same process. Only now I'm referencing the previous W1 to come up with a new W1 for the next row, for the next item in the quiz, for the next item in our dataset. I do the same for W2, W3, W4, okay? And then I do the same thing. I make a prediction, and then I check it with my answer key. My answer key in this case is 0. I do the same thing over and over again, with each iteration coming to the previous one. Okay? And then I will come up with my first iteration. Meaning to say, I reviewed all the items in my quiz, right? And then I'll check my score. Well, what is my score? My score in this case is what we call the MSE, or in other words, the sum or the mean squared. Okay, I'll just say it's the average. Okay? It's the average of all the errors that we occurred during that iteration. Okay, so it's like a summarized version of all the errors that we got in the first iteration. Now, being a good student, being a good machine learning robot, what do I do? I go through the data again. In the second iteration, I perform the quiz again using the same process. I receive the targets. After going through all 10 items, I get another value, 0.2. Okay? And then I do the same thing over and over again until I reach almost 0. Now, that one is a judgment call. I have no idea how to do a loop in Excel, so I just copy paste everything and go the way all the way to iteration 14. Now we haven't applied it yet. We're not predicting yet. We're just proving that the algorithm actually learns. And how can we prove that? Well, if we take all these MSEs or the averages of errors and we sort of graph it. Am I still sharing my screen? I'm not sure if I'm okay. Yeah, I think I'm still sharing my screen. Okay, and we graph it. Okay, so how do I graph something? Insert chart. Okay, there we go. If you were to graph it in a line graph, notice that per iteration, we are actually going down. So that's a good indicator. Our model is actually learning. Okay, because the error rate, again, as one of you pointed out here, the target between the target and the prediction is actually lowering. The difference is actually more lowering on a general sense. Okay? So this one actually proves that we are learning. And notice the weights adjusts themselves according to our formula. It is self-adjusting. It's another indication of some intelligent life form in our Excel file. Okay, good. We now have our algorithm learning. But what now? Well, what now is that after we are done studying, we take the last values of what we remember. Again, analogy of a brain. How do we remember things? What is the importance of our X? How do we prioritize each X? Remember, in this sheet, that's in column F, column I, column M, and column P. So that given some unknown X, let's say 0.5, 0.4, 0.6, and our constant 1, we get the values, our final weights. This is what we memorize, what we remember, what we have learned in our brains. And essentially, we do the same exact thing. Okay. Now, if we take a look at column Q, or sorry, column R, don't worry, you're about to end. R is our prediction, right? Our prediction, at least for the single perceptron algorithm, is a number 0.63. Now, we haven't learned much, but now this becomes what we call a predicted value that we have to apply a threshold to. And that threshold will largely depend on your problem. It depends on the domain of the problem you're trying to solve. In this case, let's just say that um, our threshold is zero point 0.5, meaning if a prediction, 0.63 in this case, is greater than zero point 0.5, then we consider it a 1. Else, we consider it a 0. Okay? So the threshold value for the single perceptron algorithm is another parameter that you can tweak that is dependent on the problem you're trying to solve. Depends on the domain, on what you're characterizing, on what you're trying to learn. And usually the one who dictates the value is what we call a domain expert. So for example, you're into stocks, then a domain expert would be someone who's into finance or someone who knows how companies operate. Let's say you're into agriculture, then a good threshold value will depend on what yield is actually good for farmers. So it really depends on the problem domain that you are learning. And there are a lot of things to consider. Again, this is just an introduction to machine learning. Okay? And because of that, we still go down to our problem or to our original mathematical equation, f of x equals mx plus b. What is a good model? That when we feed x according to some m that we learn, we are able to come up with a value to make the proper decision and reduce it to a number 1 or 0. Okay? So with that, hopefully everyone learned a little bit something about machine learning. Feel free to apply these algorithms in your own problem domain. And then to end off, let me show you a cool sort of, oh, sorry, um, a sort of magic trick. I'm not sure if Sophie's here, but Sophie's my cousin. So we have a very, very cute pamangkins. No? This, I'm not sure if it's quite clear, right? So what I did here is that using the same algorithm, the single perceptron network, okay, I fed the system pictures of my niece and my nephew, right? And just to show you an idea, let's see. Okay, this is my niece. She's a girl. Uh, I fed those pictures to a single perceptron algorithm. In that case, what is my x? Well, in the case of pictures, an x can be a pixel value in a picture. You know that in pictures, right? They are numbers from 0 to 1. Sorry, not 0, but 0 to 255. Okay? If you're familiar with Photoshop, for example. So given I believe this was a 250 by 250 picture. So each pixel is an X. So my dimensionality is 250 by 250. I kept feeding the algorithm pictures of my niece and nephew. And this is sort of the visualization that the computer remembers. And if perceptrons or neurons are part of our brain that makes us remember something, then this neural network is how machines dream of things. It's trying to memorize my niece. It is trying to memorize how my nephew looks like. Right? Okay. So with that, thank you for listening. That's the end of our presentation. Hope you learned something new. And this session gave you some ideas on where machine learning is useful and what problems it attempts to solve. Yeah, so if there are any questions, I'm open to questions.
And guys, thank you so much, Raphael. Guys, if you have questions, you guys can type it in the chat box. So yeah, okay mahiya. Type nyo lang yan dyan. And yeah, Raphael, do you want to promote what your
Okay. Yeah, sure.
okay.
Feel free to, well, Cloudband Solutions is the company that I'm currently managing. And feel free to check me out at YouTube as well. I'll post the link here.
Oh, wow. Okay. That's great. Okay, so while I ask you some questions, sa mga mayroong questions dyan, okay, mahiya, please feel free to type in your questions. Okay? So, yeah. Okay, so my first question will be, Okay, Mr. Producer, can you share the general deck? Okay. Okay, so I guess hindi naman siya share ata. Okay, so my first question for you is, what are the top three things you would advise aspiring digital marketers, or I'm sorry, aspiring or those people who want to pursue machine learning?
Um, let's see. Well, machine learning, it depends. No, how far do you want to get with machine learning? Because usually machine learning often is for data scientists, but I'd like to think that we can live in a world wherein people sort of adapt the same practices we have in machine learning, right? For example, if you take a look at the problems, those can be easily applied to other things, right? For example, you mentioned digital marketing. So these days, digital marketing is also data driven, right? You want to know your audience. You want to classify your audience as either towards some segment in the market. So that is actually a digital marketing machine learning problem where you need to gather data. So my advice would be to start, regardless of what path you take, whether you apply it to your own domain problems or you want to go into the really hardcore mathematical stuff. Regardless of that, my advice is to simply start thinking in terms of machine learning, right? Knowing how to formulate the problems uh, in terms of what do you call this, numbers, right? How do I reduce something to numbers? Okay, how do I make sure that something is measurable? Because that's the problem in the world today. We sort of make decisions based on feelings, on assumptions, on things that can't be quite measured. So if there's one advice I could give, in any problem that you're trying to solve, try to get it in some measurable aspect, some objective aspect, then usually you get good results.
Okay, thank you. So for the next question, okay, so what is one thing that you wish you would have known when you started your IT career?
Well, in that case, there are actually two things that I regret. The first one is a bit technical, and it's something to do with programming. Because usually in IT, you sort of have to do programming stuff, at least. No? Now, in programming, I thought that programming is something that you have to specialize in. That if you know one programming language, you have to stick with that. But in reality, programming and other tools as well in IT are simply just that, they're tools. If I were to focus on something, it's not really on programming, but it is on how to apply these tools. What's the best tool for a job, right? So that kind of characteristic kind of goes along with. The
Mhm.
second one is to not rely on things that the educational system gives us, especially for universities. No? Universities teaches you one thing, which is discipline. It can't further you on something that is specialized. So in terms of the IT career, I actually found more merit in learning from experiences rather than relying on. I'm not saying that schools are bad. I'm saying that you shouldn't rely on the educational system and sort of blame it for not knowing a certain aspect in your career. It doesn't have to do with IT. Although IT is sort of that situation is more prevalent in the IT industry. Yeah.
Okay, so next question. Can you give us an idea about the new challenges you're facing in IT?
Right. So the challenge here is agility, essentially. IT is an ever changing world. You really have to be nerdy in a sense that you need to keep on reading stuff. You shouldn't fall. You shouldn't be left behind with whatever new and trendy is happening. Although I do caution everyone that just because something is new doesn't mean that it's applicable to something. For example, the reason why I gave the KNN and neural network algorithms is because KNN seems quite complicated. It can do all these things like machine dreaming, but in actuality, KNN does solve problems better than neural network algorithms. One example of that is spam email. right? KNN actually solves spam email, what is spam, what is not spam, better than neural networks. Right? So the challenge is keeping up to date, but at the same time, realizing what is the best tool for the job, essentially.
Okay. So for your fourth question, what piece of advice can you tell someone who has wanted to pursue artificial intelligence?
Well, for one, try to love math, no matter how hard it is. Math is actually quite interesting if you if you know how to apply it to like the real world. The reason why math is boring is maybe because um, I don't know. Why would I like to solve for? Why would I like to prove that the angle of a triangle is this value or something in geometry, for example? So that's boring for me. But really, it's about loving these fundamental concepts. So it's not about later on when you go to the technology part. Ang daming mga advanced technologies out there. But really, if you want to advance in artificial intelligence, have a good understanding of the foundational things. Like for example, if you understood the problems I presented, you're actually better than most of the data scientists I know who only know how to use like I don't know PyTorch or just whip up a code without even knowing what's actually happening underneath the hood. Yeah.
Okay. So a question from Carabine Arnaldo. I want to explore on deep learning. How different is it from machine learning?
This is a good question because deep learning is, if you look at the formal definition, it's actually different from machine learning. We said machine learning is multivariated statistics. Deep learning shares its property with neural networks because the reason why it's deep is because you have sort of stacks of learning, um, and you're learning based on the previous learning. So neural network is actually an example of deep learning. Machine learning is not is more straightforward, like K and N. Like there's a closed form that you make a heuristic decision against. But deep learning is deep because you actually iteratively learn something from the previous thing. So anything to that tune is considered deep learning. But if you take a look at it, both deep learning and machine learning solve the same problem. Another characteristic is that deep learning is not reliant on labels, right? So it has the ability, algorithms in deep learning have the ability to learn about data even if they don't know what that data looks like. And there are algorithms that actually do that. Yeah.
Okay, so from Kai, is there a specialization in IT you'd recommend for someone who's interested in pursuing a career in artificial intelligence?
Well, in IT, okay, so in IT, not really, because IT is more applied sciences. Because with IT, you're creating like applications. I would say in IT, try to focus more on the computer science stuff, right? Because computer science is more on theory. So, for example, you learn about things like big O notation, optimization of algorithms, things like that. So, you sort of want to apply um, those concepts to artificial intelligence, right? So, in IT specifically, again, programming is just a tool. So you don't really go into programming to go into artificial intelligence. You go into artificial intelligence to learn about artificial intelligence. So it's really about knowing the fundamentals, and then you use programming to apply the fundamentals. So yeah, go to the fundamentals.
Okay, so may mga questions pa ba yung iba dyan? Okay. So parang wala na masyado. Okay. So thank you so much, Raphael. Okay, weird question from JM. Okay,
Weird
umabol pa.
question. Yeah.
If a machine learns from data that is chosen, then can people trick that machine's learning habit by changing the data?
Yeah, that's true. So yes, it's not a weird question. It's actually a fact of, and one of the problems in machine learning is that your solution is only as good as the data that you give it. So garbage in, garbage out, right? So that's the problem. One of the main problems with supervised machine learning, because in supervised machine learning, there's this window of opportunity to actually create bias in the data. Okay, so for example, if you're doing sentiment analysis, if more people are happy than sad, then most likely your KNN algorithm will give you a happy answer. When in fact the article is actually a sad article. Right? So, uh, so that's a problem. That's why a lot of work in machine learning these days and in deep learning is in the unsupervised learning, which is more interesting because all you have is data. And regardless of the bias in the data, it will actually tell you if it's biased or not. So, yeah.
Okay. So, wala na bang hahabol pa dyan ng questions? Looks like we're really learning a lot here.
Yeah, good.
Ang
Good.
daming questions eh.
I think
Ang daming
everyone liked it.
nakaintindi, yes.
Yeah,
Okay,
it's
so,
nice,
yeah.
nice. Everyone got
Yeah.
the concept across. I'm happy.
Uh-huh. Okay, so if wala na, okay, thank you so much, Raphael,
Okay,
for
you're
all your
welcome.
fruitful insights. I hope everyone has learned a lot from our skill brewing session today. Well, I know, marami naman. So, well, today we learned about what machine learning is and the types, common terminologies, etc. And yeah, it just really a lot of advantages. So, okay, so I would like to ask everyone to help immortalize this event by turning on your cameras and taking a quick photo op with us, please. Yan, very quick lang to. So yeah, open your cameras, guys. Yan, yan. Okay, yeah, quick photo op lang. Okay. Yeah, guys, smile. Okay. So, to everyone else, thank you as well for being active participants in our event. We are sure you learned a lot today, and let me tell you, it won't stop here. We do weekly skill brewing events every Thursday because we were so clingy and we want to see you guys often. Kidding aside, if you love what we do for the creatives and technology, please share and join our future events so we can continue growing our community. So before you go, I would like to ask you guys to visit and comment your suggestions on what topics you would like to learn about on future skill brewing events. And comment on our link in post, and you could just get a weekly skill brewing made just for you. While you guys chat your suggestions away, I would also like to invite you to, yeah, please do follow and like us in our social media pages. Just look up Illustrados. Okay, and yeah, we have our website and we're on LinkedIn. Okay, so also feel free to email us if you or someone you know would like to speak at our future events. Everyone is always welcome to join and connect. Again, thank you so much, Rafael. We learned so much from you. And yeah, thank you for coming to the Illustrados event. Again, I'm John, and I'll see you next time.
Thank you, Raf. Thank you.
Thank you, Raf.
Good
Thank you.
job.
Thank you, everyone. Hope you
Thank
learned
you.
something. Yeah. Bye.